This video is about all things triangle. The area of a triangle, we're accustomed to using the formula A equals 1/2 base times height, where we pick a base, usually whatever's sitting on what we think of as the bottom, and then the height is the altitude dropped at a 90-degree angle with the base. So it doesn't have to be this as the base. The altitude could actually be any number of things. So it could be that this side is the base and that's our height right there, so long as it hits that side at a 90-degree angle. But sometimes that height, that altitude, is really hard to find. And so that's where this other formula shines. This is sometimes called Hero's formula, and sometimes called Heron's formula. And it looks like a bit of a mess. For starters, what's A, B, and C? A, B, and C are the three lengths of the triangle. There doesn't have to be a height. We just need to know the side lengths. We calculate this value S by taking the sum of those side lengths, so the perimeter of the triangle, and multiplying it by 1/2. And then we take the square root of that number times that number minus the difference of each of these. Another thing about the triangle is that the sum of the angles in a triangle is 180 degrees. We talk about scalene triangles that have 3 different side lengths, isosceles triangles which have 2 of the same side lengths but the third one's different, and equilateral triangles where all 3 sides are the same. We also talk about something called the Pythagorean theorem. The Pythagorean theorem that says in the right triangle, and this is supposed to have a little right angle mark right there, in a 90-degree or right triangle, the sum of the side length, sum of the square of the side lengths equals the square of the hypotenuse. So in this case, that means 7 squared plus 15 squared equals x squared. So that means 274 equals x squared. Take the square root of both sides. Get 16.5529 and so on equals x. These numbers don't look precise past the nearest whole. So I would say that this hypotenuse is either about 16.6 or 17, whatever those units are. Let's do another Pythagorean theorem problem. So whenever we're looking for side length, we use the Pythagorean theorem. In this case, we're given the hypotenuse. The hypotenuse is always the side that's opposite the right angle. This means it's always going to be the largest side. So we take the square of the 2 side lengths, x squared plus 6 squared. That should equal the square of the hypotenuse, equals 100. So we have x squared plus 36 equals 100. Subtract 36 on both sides. X squared equals 64. Take the square root of both sides. X equals 8. This is what's called a Pythagorean triple. 6, 8, 10. It's a multiple of the Pythagorean triple 3, 4, 5. If 2 of the side lengths are 3 and 4 and the hypotenuse is 5, the numbers work out very nicely. For triangles, I'm not interested in seeing if you can just, given some information, find the area of a given triangle. I want to do problem solving with these questions, and this is a good one. When I asked my students this in the past, many have felt uncomfortable with trying to decide which formula to use. So you really need to get to the heart about what these formulas are telling you. We've talked about 3 things so far. We've talked about the area is 1/2 base times height. We've talked about how to find the area of a triangle using Heron's formula. And we've talked about the Pythagorean theorem. The Pythagorean theorem has to do with side length. It doesn't have to do with area. So if you're asked about the side length, you probably want to use Pythagorean theorem. If you're asked about the area, you have another choice. If you're given the height or altitude, the first formula is definitely less computationally intensive than Heron's formula. But sometimes Heron's formula really is the best way to go, just because sometimes finding that height is so difficult. For this question, it says in a corner of an office, a 16-foot long counter is being built. Find the area behind the counter if the two walls behind it are of equal length. So I want to find this area right here behind that counter. For finding area, I'm given both a base and a height because I know this is a right angle. 1/2 base times height is going to be the formula that I want to use. But I have a problem. I don't know what that base or height is. I do, however, know another side length, which is 16. So what I'm going to do is I'm going to use the Pythagorean theorem dealing with side lengths to find the value of x. So one side length squared plus the other side length squared equals 16 squared. This means 2x squared equals 256. Divide both sides by 2. X squared equals 128. The square root of 128. We end up with x equals 11.3137 feet. So each one of these lengths of the triangle is 11.3137 feet. This is an overly precise number, but we're going to round at the end, whether that's best practice or not. So our area is 1/2 times 11.3137 times 11.3137. I ended up with just about exactly 64. My calculator says 63.9999. I'm rounding that to 64. Since we're dealing with 3 significant figures, our answer should also have 3 significant figures. So I'm not going to leave this as 64 feet squared. My answer technically is 64.0 feet squared. Thank you.